All right, we got a fun little video. I'm going to show how I teach the metric system when I'm teaching Chem 101. I have my students just really work on just 5 or 6 things. There's obviously many different prefixes in the metric system, but I have us focus on just 5 or 6 things that I believe, or at least in my perception, are the most experienced prefix units in the metric system. So um, I broke from my what I've done in past videos where I have a lot of things pre-written. I just want to show how the metric system can be just generated by hand. You don't need to have a reference sheet or anything like that, even though those things are helpful. But hopefully with a small-ish amount, you'll be able to commit at least some of this to memory and experience. All right, so we're gonna just kind of go in this order. I'm gonna write out the different prefixes, the names of the prefixes, and then I'm gonna go with this approach. I'm gonna show 2 different conversion factors for each prefixes, 2 different ways to convert between units. Both are okay, both are good. It's just going to be a matter of your preference. The mathematical equivalence is identical. It's the same. All right, let's do it. So I'm going to write here a lowercase k for kilo, little hyphen dash for nothing. That's going to be our base unit. All right, we'll have C for centi, M for milli, and then we're going to write the Greek letter mu. Okay, that's kind of how I write my mu's. All right, if you're wondering why do we need a mu, well, the way I like to explain it, okay, we have a capital M being used for mega, like a megabyte. I'm not covering mega here, but mega would be right above kilo. And then we are already using lowercase m for milli. All right. So in this Latin alphabet, we are out of m's. All right. But we got the Greek alphabet to the rescue. Okay. This is mu. Okay. Which can be used to make an M sound as well. And mu, we're going to see, is going to be used for micro. Some fields use lowercase mc to mean micro, like maybe you'll read nutrition facts or a water quality report or something. You might see lowercase mcg for like a microgram, and that's the same as writing that. All right, in my experience in chemistry, this is the mu's used more often. That's what I like to do, so we're going to go with that going forward. All right, and then one more prefix of a lowercase n. All right, so yeah, let's write those names. Kilo. The dash is for nothing. That's just base units. Centi, milli, micro, nano. All right. Before we go on, I think it's important for you to have a feel for these prefixes, right? So I'm just going to kind of make a red line here. And then going up, I'm just going to say big stuff. Okay, we're talking about like kilometers, okay? We're talking about like megabytes. All right, big stuff going up, all right? And then going down, we're going to have small stuff. Okay, centimeters, okay, small. Okay, we're talking about like rulers now. 1/10 of a centimeter is a millimeter, even smaller. Micro, now we're talking about like hairs, like for a micrometer, micrometer, And then nanometers, you're now approaching the levels of talking about atoms and things of that nature. Like bond distances between atoms, that's like about approximately a tenth of a nanometer, maybe 2/10 of a nanometer, 3 or 4 even sometimes. Anywho, okay, so big stuff and small stuff. All right, that's going to be the theme of this video. Big stuff, small stuff. All right, so let's write out some of these conversion factors. All right, so for my first set of conversion factors, we're going to give the power of 10 to whatever unit has a prefix. All right, so for example, let's stick with meters for our examples for everything here. Okay, maybe I'll write that. We're going to go with meter examples. So let's say we were talking about trying to set kilometers equal to a meter. Okay. Everything here, it's going to have like 1 meter. All right. Everything's going to be compared to 1 meter here. So how can we make a kilometer, something that's a long distance, equal to 1 meter? 1 meter being about like 3 feet a yard. Not exactly, but about. All right. The answer would be to shrink that kilometer. Okay. 10 to the negative third power. All right. That's going to be 0.001 kilometers. Okay. And that's going to be equal to 1 meter. For the sake of space, I wanted to keep everything one page here. I'm going to be using powers of 10. All right. Feel free to consult a separate video or guide on how to convert powers of 10 to standard numbers. If people really want that in a metric context, then I'm happy to make a separate or expanded video for that. We'll just stay at this for now. All right, let's keep this going. Base is going to be 10 to the 0. Meters is 1 meter. This feels a little silly to write, but just to be complete. All right, now that we're getting to the small stuff, okay, in order to have 1 meter, we're going to need 100 centimeters, 10 to the second power. All right, you need a lot of a small thing to be equal to the big thing, right? Need the centi there. There we go. So we need 100 centimeters to be in order to get to 1 meter. Similar idea with the millimeters. We need 1,000 millimeters, 10 to the third power, to make up 1 meter. We need 1,000,000 micrometers to get to 1 meter. We need 1,000,000,000 nanometers in order to be equal to 1 meter. All right, I'll pause there for a bit, let that sink in. All right, so let's keep this going. All right, now we're going to have, for our second conversion factor, we're going to have a power of 10 on our base unit. All right, so let me show that in action. 10 to the 3 meters is the same as 1 kilometer. A kilometer is 1,000 meters. All right. 10 to the 0 power meters is 1 meter. We get the same result again. All right, let's keep this going. 10 to the minus 2 meters is the same as 1 centimeter. Okay. If we get 1/100th of a meter, that is a centimeter. And then we can just keep this going. 10 to the minus 3 millimeters. Oh, meters is 1 millimeter. All right. And you can see I'm just taking these same exponents and I'm just making them negative now. A millionth of a meter is a micron, micrometer, micrometer, whatever you want to call it. And then a billionth of a meter is the same as a nanometer. Okay, maybe I'll write this out as standard number once. 1 divided by, we need 9 zeros. There we go. All right. Cool. All right, I'll let this stay on the screen for a bit so you can catch up and let that soak in. Okay, so again, one more time a review. Okay, for this conversion factor, I had everything set to 1 meter. I had the power of 10 adjustment on whatever unit I had the prefix on. And here I put the 1 next to whatever unit had the prefix, and then I put the power of 10 on the base unit, the original unit, in this case, the meter. Okay, going all the way down. All right, my closing thought for the video is this, okay? You may be wondering, well, when should I use each? Okay, and this is where us teaching the metric system maybe run into some confusion, okay? Is one better to teach over the other, okay? Should we force students to choose? Should we tell them this one? Should we tell them that one? Or should we tell them just stick to one of them, whatever works? That's pretty much my message. I'll go a step further. For my preference, I actually just pick and choose, depending on the context, sometimes even depending on my mood. That being said, though, I'd say 99% of the time, I will go with this. Okay. And if I had anything bigger than a kilo, I would just go with that pattern, okay, above this red line here for the big stuff. And below the blue line for the small stuff, I will stick with this pattern. All right. So I like to use both. Let me get more specific, okay? I want you to see that what I did here is, well, first going here, I have a positive power of 10. All right, I say 10 to the third power, okay, 1,000 meters is 1 kilometer. In this case, because the kilometer is the big thing, I need 1,000 of the smaller thing, the meter, to be equal to the 1 kilometer. So in other words, I really like to give the big power of 10 to the small thing, okay? And that's what I did here, okay? In this case, everything here, whether it's centimeters, millimeters, micrometers, nanometers, they're all smaller than a meter. So I need a lot of the small thing to be equal to the big thing, okay? 100 centimeters to be a meter, 1,000, a million, a billion. So to summarize, if you're wondering what's my preference, okay, I'll just write it down here, okay? Okay, my preference, give the big number to the smaller thing. Give the 1 to the big thing. Oops. And you stick with this strategy, you'll notice that this big number, okay, in other words, it's always going to be a positive exponent. Okay. We're going to be working with powers of 10 with positive exponents. All right, that is my preference. I don't like to work with negative exponents sometimes, and in my experience, students, in my experience, they like working with the positive powers of 10 more often. And so for me, always stick with the positive power of 10, give the big positive power of 10 to the small thing, and then just give the 1 to whatever is the bigger thing. That strategy's always worked for me. But you may not be like me. Maybe you prefer one of these columns, and that's totally fine because math is math. All right. Thanks for taking your time to watch this. Any questions, leave them in the comments. Thanks. Take care.